The 19th of September 2025, the University of Georgia, through its Center for Applied Isotope Studies, has determined that the BUGA Sphere is approximately 12,560 years old. This dating comes with a very small error margin of 1/10 of 1%, translating to roughly plus or minus 30 years. This remarkable finding definitively places the sphere firmly during a significant climate shift, specifically the period preceding the last major ice age, an extended event which lasted for about a millennium. If confirmed, this would most certainly mean that this sphere was actually placed at a truly pivotal moment in human history. This is clearly the study right here.
Radiocarbon Analysis Report, September 19th, 2025. Sirius Technology Advanced Research LLC. Dear Ms. Nabulsi, attached are the results of the AMS radiocarbon C14 analyses and the stable isotope ratio delta 13C analyses for the foraminifera samples received on September 12, 2025. The resin sample was treated in an ultrasonic bath for 30 minutes at room temperature. The sample was dried and treated with 1 normal hydrochloric acid to remove possible carbonates. Subsequently, the sample was rinsed with ultra-pure water and dried at 105 degrees Celsius. For accelerator mass spectrometry analysis, the cleaned samples were incinerated at 900 degrees Celsius in sealed and evacuated ampoules in the presence of QO. The resulting carbon dioxide was cryogenically purified from the other reaction products and was catalytically converted into graphite using the method of Vogel et al. 1984. The ratios of graphite carbon-14 to carbon-13 were measured with the 0.5 mega-electron-volt Kais accelerator mass spectrometer. The sample ratios were compared with those measured using oxalic acid and NBS-SR M4990. The ratios of carbon-13 to carbon-12 and oxygen-18 to oxygen-16 in the sample were measured separately using a stable isotope ratio mass spectrometer combined with a gas bench and were expressed as delta carbon-13 relative to PDB with an error of less than 0.1%. The uncalibrated dates cited have been expressed in radiocarbon years before 1950, years BP, using the half-life of carbon-14 of 5,568 years. The error is expressed as a standard deviation and reflects both statistical and experimental errors. The date has been corrected for isotopic fractionation. Sincerely, Dr. Alexander Cherkinsky, scientist and senior